Good morning, students. Nice to meet you. Okay, we are discussing the last exercise of similar triangles, and we are in the fourth question. Okay, right. So, what is given in the question? PQR is a triangle right angled at P. So, fourth question, PQR is a triangle right angled at P. Okay, right. M is a point on QR such that PM perpendicular to QR. So, PM is drawn perpendicular to QR. This is what given here. Okay, ma? Right. Given PQR is a triangle. Angle P is equal to 90 degrees. PM line segment perpendicular to QR line segment. Okay, Nana? Right. Now, it is asked to show that, okay, ma? So, to show, so what is to show here? PM square is equal to QM into QMR. QM into MR. So, for 2 marks question, it is most important question, Nana. Right. So, observe PM square, that means I want 2 PMs, isn't it? To make PM square, we want PM into PM. But where do we have 2 PMs? So, 1 PM you will have in the triangle RMP and another PM you will have in the triangle PMQ. Okay, from theorem, what is the name of the theorem, Nana? Before Pythagoras theorem, we discussed theorem 8.7, isn't it? So, by theorem 8.7, we can say that triangle PMR is similar to triangle QMP. Okay? So, these 2 triangles, isn't it? Before the Pythagoras theorem, we said a theorem that a perpendicular drawn to the hypotenuse will divide it into 2 triangles who are similar to each other and also similar to the total triangle, isn't it? So, basing that theorem, now we want here PM. So, I take PM, here that is MQ or QM. So, therefore, PM by QM is equal to, here I take MR, so here I take PM. So, MR by PM. Now, make the cross multiplication PM into PM, it becomes PM square is equal to, now it multiplies here, you get QM into MR. Did you understand? We complete our proof. It's very, very simple, Nana. Okay, ma? Right. Now, we come to the next theorem, next question, that is 5th question, Nana. In the 5th question, also the same procedure, you follow the same method. ABD is a triangle right angled at A. Okay, diagram is already given for you. ABD, where right angle at ABD, and AC is the perpendicular drawn here. Okay, this is given to us. So, we write given ABD is a triangle, angle A is equal to 90 degrees, AC line segment perpendicular to BD line segment. Okay, Nana? Right, very good, very good. Ask you to show here, to show, what is to show? Yes, first one, AB square is equal to BC into BD, very good. Come on, tell me the second one. AC square is equal to BC into DC, and the third one, AD square is equal to BD into CD. BD into CD. Okay. So, we want to prove these 3. It's very, very simple. Same theorem from theorem 8.7. Okay. From theorem 8.7. So, what do we know? A perpendicular drawn from right angle vertex to the hypotenuse will divide it into 2 triangles which are similar to each other and also similar to the whole triangle, isn't it? Right. Now, first AB square, you have AB in 2 triangles. So, for the first one, triangle ACB similar to triangle DAB. Okay, because this triangle I have taken this triangle, here I have AB, and in the total triangle I have AB. Here you have A90, in this triangle you have C90, in the total triangle you have B, and in the small triangle also you have B. So by A similarity these two triangles are similar. When they are similar, you can equate the, you want AB, so I take AB here, and here is BD or DB. So AB by BD is equal to, here you have AB, so here we have BC, so BC by AB. Okay, now make the cross multiplication. So what do you get, Nana? AB into AB, you get AB square is equal to BC into BD. Is it clear? Right. Coming to the second one. What is the second one? AC square. AC is present in the middle. That means you have to take the two small triangles, isn't it? So I am taking the triangles. Triangle ACB, similar to, you should not take A again, because A and A are not equal, Nana. So for B, this A will be equal. So triangle for A, I am going to take DCA. Observe, you must be very careful while choosing the triangles. Okay, ma? ACB. So ACB, C must be corresponding. A must not be along with A, it must be differentiated. So A corresponds to the other side, B. So DCA. As you want AC here, see here AC, and here you have DC. So AC by DC is equal to, here you have AC and here you have BC, BC by AC. Now make the cross multiplication. AC into AC, it becomes AC square is equal to BC into DC. So what we want and which triangle we have to select, that is most important. So as we wanted AB square here, we have selected this AB in the small triangle and the total triangle. Similarly, I want AC square here, AC is in the middle, that means it is in these two triangles. So we selected the two triangles. Similarly, we come to the third one. Can you tell me what triangles we are going to select? What do you want here? AD square. Where is AD? This is AD. So AD square comes into the small triangle and also in the total triangle, isn't it? So we take triangle ADC, similar to, okay, this C is corresponding to A, so I take lost A. D corresponding to D, I take D, and what is remaining there for me? B. So B. So this is the way you have to select. 90 degrees goes to what? A. Here you want AD square, isn't it? 90 degrees go to A. Yes, C is 90, and in the total triangle A is 90. So C corresponds to A, and D corresponds to D because it is common angle, and A corresponds to B. Okay, Nana? Right. Now what do you want? You want here AD square, so select AD. AD by here BD is equal to, here again you have AD, so here CD, CD by AD. Make a cross multiplication, you get AD square is equal to BD into CD. Okay, Nana? Did you understand, everybody? Very good. Practice these two questions and try to do the sixth question as your homework. Okay? Bye. Once again, see, it is informed by the management that from tomorrow onwards you must get your all classworks and get and make corrections here. Okay, the teachers will be available from 10 to 1, and you all people must be attended and make your corrections, all the classworks. Okay, thank you. Bye.